I'm Anil Kumar. Welcome to my series on permutation and combination. On request of many of my subscribers, in this video, I'm going to discuss few tricks to solve permutation combination questions. Now, I've selected questions from previous test papers and taken care of tests like IIT Joint Entrance, CAT, SAT, and many competitive exams. So the selection of questions cover the topic in details. In this video, we will discuss distribution of identical objects, right? So we'll talk about distribution of identical objects in different groups. We'll have two cases, one without conditions and the other with conditions, right? Based on these cases, here are four questions. Question number 1. Number of ways to distribute 8 diamonds in 2 persons. Question 2. Number of ways to distribute 8 diamonds among 3 persons. 3. Number of ways to distribute 8 diamonds among 3 persons so that each person gets at least 1. So that is kind of a condition. So that belongs to case 2. Question number 4. Number of non-negative integral solutions to following equations. Now we have 4 different types of equations. It's a good variety to begin with. We'll take up more equations in the next part of the video. So let's begin by understanding the concept and then we'll apply those tricks to solve these questions very fast, right? That's the whole idea, to save some time, especially for multiple choice questions, correct? So let's begin with case 1, without condition. Now here we need to find number of ways to distribute 8 diamonds in 8 persons. Now when we have to distribute, why not distribute diamonds, correct? So let's say these are the 8 diamonds for us, right? So these are 8 diamonds and we need to distribute them to 2 different persons, correct? Now, in that case, condition could be that one person gets nothing, the other one get all 8, right? That could be the case, since there is no condition. Or we could have combination 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, 1, or all 8 to the other side, right? So that gives you 9 particular ways of doing it. Is that clear, right? So that gives you 9 particular ways. Now that was simple. The numbers are very small, so we could easily figure it out. Now, how do we apply what we've learned in permutation and combination to get a fast answer to this question? Well, what we could do here is that we could use a line as a separator, right? Like this. So this divides into 2 groups. Do you see that? Correct? So we could divide like this. So this is like one person getting all 8, the other getting nothing. And then in this position, what we get is 1 and 7. And then this is 2 and 6, 3 or 4, 4 or something like this. Do you see that? So we have a position kind of like this where we introduced another item which is different from those like items, correct? So let me show that different item using this particular block. Okay, so what do we have now? What we have now is basically 9 elements, right? 8 and 1 we introduce. Now the question is, we need to arrange all 9 elements, out of which 8 are same kind. So we know from what we have learned, 9 elements will give us 9 factorial divided by 8 of one kind means divided by 8 factorial, and that gives you 9, right? That gives you what we wanted. Do you see that? So we could get a result like this. Now in the form of combinations, we could also write this as 9C1, correct? 9C1. And you can use calculator to calculate. You will get 9 as your answer. Now we're trying to just, get a formula. some way or the other. And I think that works, correct? Now let's look into the second question, which is number of ways to distribute 8 diamonds among 3 persons. Now, I have to distribute amongst 3 persons. Well, let's try to understand this situation. In this situation, we were interested in distributing among 2 persons. So P was 2. We took 2 minus 1 as new block, right? So we introduced that. And we had 8 diamonds. So in all, this is equal to 1. It became 9, C, and 1, since we had this 1 type, correct? So we can, it's looking like this. We have to position this somewhere, right? So that one position we're looking for. Does it make sense? Now, if you're looking for 3 persons, we need to have 2 columns or 2 separators. Do you see that? So if I introduce another separator here, so I could make 3 different groups, correct? And accordingly, I can actually make different number of combinations, as you can see, right? Just transferring one to the other place. So that helps to visualize the situation. Now what do we have? We have in all 8 plus 2, which is 10, right? So we have 10, and we need to play around with these 2. So 10C2 becomes our solution, correct? Now, does it work for us? Let's see. We could do like this. We have total 10 elements, right? So we have total 10 elements. So we call them arrangement of 10 is 10 factorial, out of which these 8 blues, 8 diamonds, right? So, and these two separators. So that is what we get. So technically, we do get something which is 10 factorial over 8 factorial times 2 factorial, and that happens to be same as 10C2. Do you see that part? Correct? Does it make sense to you? I think it does. So I think with this visual, you could remember how we derived the formula, right? So basically, if D is the diamonds, let's say if D is the diamonds, right, and P is the persons, we are taking one less person, right? So we are adding to our diamonds one less person, right? So that gave us 9 in the first case, 10 in the second case. And here, see how many intruders we had? One less than the person, right? So P minus 1. Do you see that? So that becomes our formula for distributing identical objects when there are no conditions. That is to say, we could give even 0 diamonds to a person. We could give 1 to any number. Does it make sense to you? Right. So this is a very important formula which we have derived. And I'd like you to go through this part once again so that you understand this concept, correct? And from here, we are going to solve all the questions, correct? From here, we are going to solve all the questions. Now let's look into question number 3, where we do have a condition. So the formula derived was, let me write here, without condition, the formula is number of diamonds we are taking, we are adding P minus 1, C, P minus 1, correct? That is the formula which we just derived. Now let us see how to modify this with given conditions, right? So question number 3 says, case 2, with conditions, number of ways to distribute 2 diamonds among 3 people or 3 persons so that each person gets at least 1. Now we have a condition that they get at least 1 diamond, each person. Well, so let's do one thing. We'll again introduce our separators, correct? We introduce our separators. So these are the 3 groups. Let's give 1 to each. So the condition is met. Do you see that part? So what we did here was that we have our separators and we just distributed one each. So the condition is met. All of them, all three, have got one each, correct? Now, I could distribute these 5 any way I like without any condition. Do you see that? So that means now I could apply this formula. The only thing is that I'm left with only 5 diamonds, right? So the result is these 5, number of persons still 3. So 3 minus 1, which is these 2. So we get 7C2 as our answer. Does it make sense, right? We already given 1, so we have met the condition, and we are left with 5. Now this is without condition, right? So distributing 5 diamonds in 3 persons. Correct? So that is 7C2. So that is how we can actually apply our formula, which we just derived, to improvise the conditional cases also. Do you understand this part? So that's the beauty of it, correct? So we'll only work with one formula, which is number of diamonds plus number of persons minus 1, because minus 1 is the columns which divides into 3 different groups. In this case, it should be 2 columns, correct? Now, let's move forward and then solve the equations from this particular logic, correct? Now, from our example on distributing diamonds to persons, we derived the formula, that is number of diamonds plus 1 less person combination is 1 less person. So those are the divisors, kind of. Is it okay? So that is the formula. Now, let's see how to solve or improvise this formula for different kinds of equations. Now, these are very critical questions. Question number 4. Determine the number of, so question number 4 is number of non-negative integral solutions to following. So we'll take the first equation, which is A plus B plus C plus D equals to 20. Now in this particular case, you can think like this, that we have 20 diamonds, right? So we have something to distribute, right? And these are 4 different persons, right? So these are, think like this, these are 4 different persons. And these are 20 diamonds. Now there is no condition. We could give all those 20 to one person. We could distribute them equally, like 5, 5, 5 each, or any way we like. Correct? Now if I treat this like we treated our diamonds and persons, then what do we get here? Since there are 4 persons, I need 3 separators, correct? This time I need 3 separators. So the formula becomes 20 is the number of diamonds, so we get 20 plus number of persons is 4, 4 minus 1, C, and number of separators will be 3, that is 4 minus 1, correct? So the solution will be 23 C3. Does it make sense to you? So that is the trick, correct? Immediately you get the solution. Does it make sense? Now I hope the formula has been registered in your mind, right? Now here is next question. The next question is very critical. We have this time 2 conditions. That is, we want to say that A plus B plus C plus D, okay, plus E is equal to 20, and we have 2 conditions, and A plus B is equal to 5. Now both equations should be true. This is the AND condition which we have to work on, correct? How do we solve such question? Think about it. Now what we can do here is that we can divide it into 2 parts. That is to say that, let's treat it like this. We want to distribute 5 diamonds among A and B, and out of 20, what remains? 15. So C plus D plus E, they get 15 diamonds. Do you get an idea, right? So two persons, 5 diamonds. So it is 5 plus 1, 6. C1 and means multiply. And this is 15 persons. 15 diamonds, 3 persons. That means 2 separators. So 15 plus 2 is 17. C2. You get an idea. So the solution of second equation is 6C1 times 17C2. Does it make sense to you? So that becomes the solution for the second equation. Correct? So I hope you're kind of appreciating it, right? So it is that good. Now we'll do part C and D, which are very tricky equations. And let's see what additional things we have to improvise to use this beautiful formula of distributing diamonds to persons, right? So the formula is diamonds plus persons minus 1, C persons minus 1. Okay, that's the formula. Okay. Now, it is combination of case 1 and 2. So we are doing without condition and we are also doing with conditions. C. A plus B plus C is less than equal to 20. Now, it's not equation. It's now an inequality. How do we solve this? Now, to solve this, it really means less than equal to 20 means it could be 0, it could be 1, 2, 3, 4, like this, correct? Now, to convert it into an equation, see the change which I am going to do. I am going to treat this as A plus B plus C plus, let me use another number here, let's say n, is equal to 20. So we can add some number so that it becomes 20 all the time. Do you see that? Now in this equation, when we say non-negative integral solutions, we know A, B, C and n all should be greater than or equal to 0, right? Non-negative. So basically, if you look into it, we again have 20 diamonds, right? Think like this. What do we have now? We have 20 diamonds. And this time we have 4 persons. So if I have to distribute, I need 3 separators, right? 3 separators. So I have to add 3 to this. So what do I get? If I add 3 to this, I get 23 C, and there are 3 separators. That's the result, which you get the same by applying the formula. Does it make sense to you? Now that's the tricky part, correct? This is how we could improvise our learning into different conditions, and that takes you to a much higher level. We'll actually take more critical equations and different examples which you could see in IIT JEE papers. Now let's look into the last question. A plus B plus C equals to 20, but we are giving a condition that A should be greater than or equal to 2 and B should be greater than or equal to 1. That means C is greater than or equal to 0, no condition basically, and we are saying A is greater than or equal to 2 and B is greater than or equal to 1. Okay, so the question here is that A plus B plus C should be equal to 20 with the given conditions. What should I do? So as we did in the very first example with condition, we'll actually give 2 points to A, that is 2 diamonds to A already, 1 diamond to B. So we have already given 2 and 1. So we're left with what? We are left with 20 minus 3. So we get a new equation which is A plus B plus C equals to 20 minus 3, which is 17, correct? A has already got 2, right? A already has got 2, so that's it. B has got 1. So that means we have met the condition. Now we have 17 diamonds to be distributed in 3 different people. So 2 separators, so that means 17 plus 2 is 19. C2. That becomes the solution for the given question. Now, does that make sense to you? Right? So, we actually solved all these questions in no time. Now, let's look into our questions and write down the answers. I will actually like you to pause the video and answer all these questions now. Okay? Take a minute. Let's go through them once again. So we talked about identical objects, which were diamonds for us, right? These diamonds. And then we had these separators to separate them. With and without condition. First two examples are without condition. Number of ways to distribute 8 diamonds in 2 persons. So we need one separator. So we get this time 9C1. There were 9 ways, correct? The second one is number of ways to distribute 8 amongst 3 persons. So for 3 persons, we need 2 separators, right? So we added 2 to 8. So we got 10 for this, right? So we got 10 for this. Let me write here 10C2. That was our solution, correct? Now, in the third case, number of ways to distribute 8 diamonds among 3 persons so that each person gets 1. So we gave 1 to each. So that means we are left with 5 diamonds. So it is 5 diamonds and 3 persons, right? So 2 separators. So we get 5 plus 2 is 7, C2. Does it make sense to you, right? So we got 7C2, the answer for question number 3. Now question number 4 is to solve an equation where the sum could be 20. Any numbers could be distributed, non-negative. So we are saying in this case, A, B, C, D are all non-negative, means greater than or equal to 0. Okay? They could be 0 also. Now think about 20 diamonds, 3 separators. So we get here, in this case, we get 23 C and 3 separators. Got it, correct? In this case, we introduced another. So we wrote this as A plus B plus C plus D equals to 20, correct? So we got 4. So we need again, so it becomes kind of same, right? So we again get 23C3 as our answer. Okay, great. Now in this particular case, we have 2 different conditions. So we are working with 2 people getting 5 diamonds and 3 people getting 15. So 2 people getting 5 diamonds and 1 separator means 6, C1 times. Here, 3, these 3 will get 15, right? So 3 means 2 separators, 17C2. Just multiply, get your answer. The last one, A should be 2, B should be 1. Let's give 2 to A, 1 diamond to B. We're left with what? 17, right? So balance 17 amongst 3 people. So that means 2 separators. So we get 17 plus 2 as 19, C2. That's the answer. So I hope that makes sense, right? So that is how you could do the cases which involve distribution of identical objects with or without conditions. Does make sense to you? Feel free to write your comments and share your views. We'll take up more videos on these tricks and I hope they really help you. Thanks for watching and all the best.